US Physics Olympiad, year 2022. F = MA, exam A. This year was split by two equal competitions, and students could participate in any of them. As usual, it was given 75 minutes for 25 problems. If you want to get more interesting problems, subscribe for this channel, please. Problem number 1. A projectile is thrown upward with a speed v. By the time its speed has decreased to v/2, it has risen a height h. Neglecting air resistance, what is the maximum height reached by the projectile? Problem number 2. A car is moving at 60 miles per hour. When the drivers notice an obstacle ahead, hitting the brakes, the driver decelerates at a constant rate and manages to come to a stop just barely before hitting the obstacle. If the car had instead been moving at 70 miles per hour and started decelerating at the same place and at the same rate, with what speed would it have hit the obstacle? Problem number 3. Two blocks of mass m have an inelastic one-dimensional collision. Initially, the first block is moving with the speed 5 meters per second and the second is at rest. After the collision, the first block is moving with the speed 2 meters per second. What percentage of the system's original kinetic energy was lost during the collision? Problem number 4. A mass on an ideal pendulum is released from rest at point 1. It swings over to point 2, at which point the string suddenly breaks. Which of the following shows the trajectory of the mass? Problem number 5. A uniform solid ball with mass m = 1 kg and radius equal 10 centimeters rolls without slipping on a horizontal plane so that its center of mass has velocity v = 1 meters per second. What is the ball's total kinetic energy? Problem number 6. A bulk of mass m hangs from a rigid massless rod forming an ideal pendulum. The rod is held horizontally and released from rest. What is its maximum tension during its swing? Problem number 7. The following graph shows the results of measurements of two physical quantities, y and x. What is the following best describes the functional dependence of y on x? Below, a and b are positive constants. Problem number 8. A block of mass m is placed on a wedge of mass m inclined at an angle theta to the horizontal. The coefficients of friction between the block and wedge and the ground are high enough for both the block and the wedge to remain static. What is the magnitude of the friction force of the ground on the wedge? Problem number 9. A person is holding a massless rope on which hangs a mass m as shown at left. To pull the end of the rope with a constant upward velocity v, the person must exert a force Fv. To pull the end of the rope with a constant upward acceleration a, the person must exert a force Fa. Now the rope is wrapped around a fixed massless pulley and the mass is doubled to 2m, as shown at right. Compared to the original setup, how does the forces Fv and Fa needed to pull the end of the rope with a given upward velocity and acceleration, change. In both cases, ignore friction and air resistance. Problem number 10. The two ends of a uniform rod of length 2L are hung on massless strings of length L. If the strings are attached to the ceiling and the rod is pulled a small distance horizontally and released as shown, what is the period of oscillation? Problem number 11. Two identical spherically symmetric planets, each of mass m, are somehow held at rest with respect to each other. Each planet has radius r, and the distance between the centers of the planets is 4r. If a rocket is launched from the surface of one planet with the speed v, what is the minimum speed v so that the rocket can reach the other planet? Problem number 12. A pulley is constructed by attaching two concentric cylinders with the larger cylinder having twice the radius. Ropes are wrapped around both cylinders. Mass m is hung from each rope and the system is released from rest. Neglect the masses of the cylinders and the ropes. Each mass experiences both a gravitational and a tension force. If the net force experienced by the left mass is F1 and the net force experienced by the right mass is F2, what is the ratio? F2 over F1. Problem number 13. Consider a laptop made of two identical uniform plates, each of mass m over 2, connected by a hinge. The hinge is locked when the screen makes an angle theta to the vertical, as shown, fixing the angle between the two pieces. Assuming the laptop does not slip, what is the minimum force that can be exerted on the top of the laptop in the plane of the page to cause the bottom of the laptop to lift off the ground? Problem number 14. A small block is released from rest on the rim of a fixed, frictionless hemispherical ball. From the time the block is released until it reaches the bottom of the ball, which of the following is true? First, the speed of the block never decreases. Second, the magnitude of the horizontal component of the velocity of the block never decreases. Third, the magnitude of the vertical component of the velocity of the block never decreases. Problem number 15. An egg is launched with the speed v from the ground, a distance d from a vertical wall. If v is high enough for the egg to hit the wall, which of the following could describe the angle theta that maximizes the height h at which the egg hits the wall? Problem number 16. A hexagonal pencil of a uniform density lies at rest on a horizontal table. It is pushed horizontally with a steadily increasing force halfway up its height as shown. What is the minimum value of the coefficient of static friction between the floor and pencil, so that the pencil will eventually begin to roll? Problem number 17. A thin rod has a non-uniform density. It is mounted on an axle passing perpendicular to it through its center of mass as shown, and is then rotated about the axle. The axle divided the rod into two parts, one on each side of it. Which of the following must be true, no matter how the mass in the rod is distributed? Problem number 18. A cylindrical piece of cork of density rho c, height hc and the cross-sectional area AC is in a larger empty cylindrical container of a cross-sectional area AW. Water of density rho W greater than rho C is slowly poured into the empty container. What is the height of the water in the container when the cork starts to float? Problem number 19. A toy elephant is standing on the bottom of a fish tank. The fish tank is filled with water to a depth of 10 centimeters, completely covering the toy. The elephant's legs are perfectly polished, so that there is no water between the bottom of the legs and the tank's floor, and the total area of contact is 0.16 square centimeters. The water has density rho equal 1000 kilograms per cubic meter. The toy has uniform density 2 rho. The atmospheric pressure is 10 power 5 Pascal, and the toy has a total mass 120 gram. What is the total hydrostatic force that the water exerts on the toy? Problem number 20. A bead is threaded on a frictionless wire and launched horizontally from height h with the speed v0 as shown. If the shape of the wire is a step, as in curve 1, then the normal force from the wire on the bead will point inward. If it is shallow, as in curve 2, then the normal force will point outward. There is exactly one possible shape of wire, shown as a dotted line, for which the normal force of the wire on the bead is always equal to 0. What is the horizontal displacement d of the bead when it travels along this wire? Problem number 21. A cork floating in a cup filled with viscous fluid is placed in an elevator. Below is a plot of the velocity v of the elevator as a function of time t. Which of the following plots best describes the height h of the cork in the cup as a function of time? Assume that the fluid is viscous enough to dampen all oscillations, that the fluid does not slosh as the elevator accelerates, and that both the cork and the fluid are incompressible. Problem number 22. A block of mass 2m is placed symmetrically on two identical wedges of mass m as shown. All surfaces are frictionless, and the wedges have angle theta to the vertical. If the system is released from rest, what is the downward acceleration of the block? Problem number 23. For objects moving through air, the force of air resistance can be modeled as proportional to the speed, linear drag, or proportional to the square of the speed, quadratic drag, depending on the circumstances. Two identical objects A and B are dropped from the same height h simultaneously, but object A is given an initial horizontal velocity v. The objects hit the ground at time ta and tb. Accounting for air resistance, which of the following is true? Problem number 24. A satellite is in orbit around a planet of mass big M. Its maximum distance from the center of the planet is d, and at this point it is traveling at the speed of v equal 1/2 multiplied by square root from gm over d. What is the area of the satellite's orbit? Problem number 25. A cylinder is placed with its axis vertical, and the rubber band of mass m and tension T is wrapped horizontally around it. What is the minimum coefficient of static friction μ between the rubber band and the cylinder such that the band will not slide down the cylinder?